Hi there, welcome back. My name is Wei, and I'm a developer advocate from Google ML team. Today, we're going to take a closer look at KerasCV in one of the most common machine learning use cases, image classification. We will start with basic inference with a pretrained classifier, then we'll fine-tune a pretrained backbone, and finally, we're going to take the more advanced task of training an image classifier from scratch. First, basic inference. KerasCV offers a number of pre-trained backbone models, including EfficientNet, MobileNet, RateNet, and so on. You can find the complete list of backbone models in the GitHub link below. In this case, we just load the EfficientNet v2 model pre-trained on ImageNet datasets using the simple FromPreset API. Let's take a cat image as a test. Now we have the classifier and the test image. We can just call the predict method and we will get the prediction result. Finally, we look up the top two predicted classes from the label file, and we can get the right class, Egyptian cat. As you can see, with just a few lines of code, we have used a pre-trained model to classify an image. It's super simple. Moving on to fine-tuning a pre-trained backbone model. While we can directly use a pre-trained EfficientNet model to make predictions, we can improve accuracy by fine-tuning a custom classifier. As an example, we're going to fine-tune a model for classifying cats and dogs. We first load the cats and dogs dataset, and we resize the training data as preprocessing using a helper function defined before. We can take a peek at some preprocessed sample images. Now we load the EfficientNet model again and compile the model. Note that this time we specified number of classes as 2, since there are only 2 labels, cat and dog. Then we call the familiar fit method to kick off fine-tuning. After training is finished, we can run the prediction and get the result, cat. That's it for fine-tuning. Our next topic is more advanced, training an image classifier from scratch. This time, we're going to use the CarTech 101 dataset. We split and shuffle the data here. Then we batch the dataset and visualize a few sample images. The CarTech 101 dataset has different sizes for every image, so we use the ragged batch API to batch them together while maintaining each individual image's shape information. We may also perform some data augmentation here, but in the interest of time, we're skipping that part. Our next video will focus on data augmentation, so make sure to watch that one. Next, we define the optimizer with a warm-up cosine decay schedule. The specific detail of this schedule is not very important here. Next step is to build our model by stacking a few layers on top of the EfficientNet v2 backbone. We also define the categorical cross-entropy loss. Finally, we compile and fit the model, and the KerasCV will train a powerful classifier for you. So in conclusion, from what we have talked about today, you can see how easy it is to leverage KerasCV and reuse the built-in models and modules to build powerful image classifiers. In our next video, we're going to cover another important topic, data augmentation. See you next time.